And we're going to be building our project today. We're going to actually be building the idea of building our tree node. We just talked about that structure up there on the board earlier, so we're going to actually go in and build that right now. And so we're going to talk about the process that goes along with this. And so what we need to do is we actually need to go to our Xcode. If we do Command 1 to open up the side window, we can go over here to our model package. And in our model package, we're going to add a new file to it, or a new class. So you can either right-click and choose New File, or you can go up to your drop-down menu on the top and go to File, Add New File. Both work just great. We're going to be inside the model package for it, though. So right-click and New File. And on New File, it's a C++ file. And then go to Next.
TreeNode, CPP, and HPP.
And TreeNode. And call it just TreeNode. I'm calling it PM just for purposes that we can build it here with you in class. And create a header file. We want to make sure it's in our model group and inside our model subfolder. This is so we can keep our code organized. Again, we're using that model view controller structure we've used all year long. And then I hit create. Now, if you notice right here, it creates it as a TreeNode.hpp and .cpp. If you don't like the .hpp extension, you can change that. You can just click on it right here and just call it .h if you want. I'm just going to leave it as .hpp right here because it works easily for that. My pound include, I don't need to pound include stdio.h. However, I do need to pound include node.h because that's right there as part of our process. That's part of our project we're working from. We just talked about how it's going to inherit from that. So go ahead and do that and hit save because saving is good. And so we have right here, if I save, I should commit. Exactly. So let's go over to GitHub. And notice, I have that lovely add right there of TreeNode PM at .h and .cpp. Using full sentences for my commit message and commit to master. As you can see, I have a nice big series of commits happening today on that. And so my first line right here is the pound include. We know this is a pound include statement. This is what's called a preprocessor notice. When it's dealing with the preprocessor, what does it not have at the end of the line? Semicolons. Semicolons, because it's not read by C++. It's read by the linker. And so we don't put semicolons on these lines because they're read by before C++ gets it. And so we skip out all those lines. Inside our pound include, we have to include our base class because that's how we're going to be dealing with that. And we're going to go inside here. And I'm using a namespace on my code. So I'm going to use that for this. You don't have to use a namespace on yours. Like I said, I'm using a namespace for mine. You do not have to use yours, but I'm going to go ahead and get that set up. So we have, first thing we have to do is we have the fact that we're going to be doing the namespace for mine. So you don't have to have this on yours, but on mine, since I'm on the project that I'll be giving you for the base framework as well, I'm using namespace. So namespace, and I'm calling it ctech_data. And then inside my namespace ctech_data, we have the idea that this is going to be a template, and it's a class, and it's going to be TreeNode PM, and it's going to inherit from public of node of type. And remember, our classes inside C++ end with our great friend the semicolon. And I have a private section and a public section that belong to my class files. So go ahead and you can save that. Again, if you're not using namespace, don't worry about that, what I've got in my code for namespace. You'd leave that completely out of your code. All you would have is the template class up to this spot because that's what you're using for that. So again, we're making a class for this TreeNode PM. And it's a public inheritance. And then what I'm inheriting from, I'm inheriting from node. And if we go back up to our ctech_list.h, we can see that, our ctech_list, our arraynode.h. We have that same idea right here where I have that template class type. The class arraynode inherits from public of node. It's that same approach that we're doing for that, except instead of using a list node or an array node, we are now making our tree node. So it's that same basic format we had for that. And so we have that format we'll be using for all this in code. So in our private section, we just had up here on the board that we're going to be working with, we have 3 data members we have to keep track of as part of our TreeNode object. And they are of type TreeNode pointer. So let's go ahead and make those. So we have a TreeNode of type, and it's a pointer to it. And so we have left child, and then right child, and parent. So we have 3 data members that we have to deal with for that. Those 3 private data members of our tree node. Each tree node will have those 3 data members as part of it, and they're private data members. Because we inherit from node, we also have a value, but that's going to be part of the actual constructor. We don't have to specify it again because we've already specified it inside node. But we are going to have to make sure we have attached to this right here in our private section, we need some getters and setters for these 3 data members. So let's go to our public section and let's identify our getters and setters for that. So our setters, what is the rule for all setters? What's the return type on all setters?
Void.
Void. So we have a void, and then the naming convention for all setters? Set, and then the name. Very good. So we have set, and then parent, set left child, and set right child. And for a parameter, it's going to take the type. So I'm actually going to go up here and just grab this line right here, that copy, and paste it back in. And so my set left child will take as a parameter a TreeNode PM of type and called left child. And I'm going to copy that. And instead of set left child, I'm going to add a set right child. And change this also to be right child. And set this one for parent. So I have my 3 setters. They're all of type void. They're all created right there all at once. And so I have my setters for that. I also need to make getters for each of those. What is the rule for making a getter for a method? The return type will be the type of the data member. So I'm going to go up here and grab the return type, copy that, paste it down here. So it's a TreeNode type pointer is the return type. It's a public method. And what's the name for our getters? Get and then the name. Very good. So left child. And what parameters do getters have? None. There are no parameters for any getter. So I've got my get left child, my get right child, and my last one, get parent. So I have right now that beginning of my class, I've got my 3 data members right here. They're in my private section because they belong to the actual object and they're private because we're using good object-oriented programming technique where we keep our data members private. We have accessors to either change or retrieve those values inside our getter section and our setter section. Those are both public methods for each of those data members. Also in our public section, we need to be able to construct these objects. And we're going to make 3 different constructors for a tree node. So we have a tree node of type constructor. And we're going to have a tree node that takes a const type parameter value. And we'll take a tree node pointer that takes a const reference to the value as well as a tree node pointer parent. Because we'll have to create a one that has a parent to it. So we have 3 parameters on this for a constructor. A default constructor we probably won't use very often, but it's good to make one just in case. A tree node constructor that takes a value, and a tree node constructor that takes a parameter for the value as well as a parameter for the parent. So we can refer to who the parent is of that object. So we have right now our header file. Again, we grab this right here so you can get a screenshot if you need one. If you don't need the data space for your, or excuse me, the namespace for your project, that's great. I'm using a namespace for my project just to organize my data a little bit more. And so on mine, I have my namespace of CTech data, which means that this class all right here is part of that namespace. That's how that's going to be used. You don't have to have that. You can simply have just this code right here for your project. That's not required for you to use a namespace in this component. But everyone should have these 3 data members and these 3 constructors, 3 setters, and 3 getters. So I've got my TreeNode header file created. I've got my design done. We'll be working at adding this to our umlet for this later on, where we actually add a UML diagram for this. So we'll talk about how this is set up, because we did the design on the board this time instead of on UML to set it up. But that same process will apply for it. So we have our basic structure right here. So now what we need to do is we need to go ahead and start building this in code to see how we're actually going to build these pieces. So now we've got our header file done. Let's go ahead and I'm going to do Command O or 0 to close that down, and do Alt Command Enter to open up my assistant editor. And that gives me access to my implementation file over here on the right, so I can see what's on my left, what I have to make sure I implement on my right hand side. So because I'm using a namespace in my code, I have to add the using namespace. If you're not using a namespace, you don't have to worry about that line, but that's what I'm using inside my code. And then to write the implementation for this, we are going to go ahead and start with our constructors, and then I'm going to have you guys write your getters and setters on your own. So first thing we need to do, for all methods in our implementation file, what's our first line for all of our lines of implementation file? Okay, so our template class type is going to go before each line. And we're going to start with our constructor. And so it's going to be the return type, which is nothing. So we just write down the class name. And so a TreeNode, PM, and it's of type. And then scope resolution to say who owns it. And the name of it is the constructor, so TreeNode. So I need to show my inheritance inside this file, though. So we need to show that we're inheriting the constructor, or we're using the inherited constructor. So to do that, making sure we have our Xcode open as well, and we're not just using my Xcode. So I'm going to do a colon right here to say I'm accessing the superclass. And I'm going to do node of type, because my base class right here, TreeNode PM, is the owner of the class, the constructor itself, and then I'm going to call the super constructor right here. So I'm going to do colon and then the super constructor after that. So that's how I'm calling the super constructor. What's that? Because so I can set up any values that exist inside my default class, in this case node. So I want to set my value to be null, and any other components that I know that are inside node.cpp to also be initialized. And then the job of the constructor in Java, C++, in fact every language, what's the role of the constructor? Initialize values. And so I have 3 data members right here. And what are the default values for pointers? Null pointers. Let's do that. So let's say left child. This selector, left child, equals null pointer. This selector, right child. So I have initialized all 3 of my data members. Now in C++, I can't call constructors within constructors like I can inside Java and Swift. So I can't just refer to this default constructor and call it all the way through it. So I'm going to have to use those same 3 lines of code inside all my other constructors. So we have 2 more constructors to write. And so we're going to write this next constructor that takes a parameter. And then we're going to review how to call a parameter constructor with this. So again, we start off with all of our first line, the template class type. So just copy pasta that line. And then again, it's also going to be owned by the TreeNode PM of class type. And for our scope resolution to show who owns it. And now we're going to call the constructor that takes a single parameter. So I'm going to grab that same parameter header right here. We need that whole line, so I'm going to copy that and paste it right here, because that tells me I'm going to call a TreeNode constructor, passing it a constant reference to that value. And this is all in one line still, as you can see, is still line 21. And then I'm going to call the super constructors parameter node of type, but I'm going to pass it the value. And so I'm going to pass value to the super constructor, because I'm going to use the super constructor's reference for that. So I'm going to call the super constructor's value parameter with this. So this is going to call the super constructor. It's going to go up to value, and it's going to do the work of value in a super constructor. So this parameter right here, value, gets sent to the super constructor of node as a parameter. So it can do that job for us. We're going to override it just to make sure we're good. but we're actually sending the work for us right here. We're going to double check to make sure it works, though, in our code. So save that. And these 3 lines we still need again, but we can't call the constructor inside a constructor, so we just copy pasta. If you want to retype it, go ahead. But we have to do those same exact 3 lines right here, so I'm just going to copy and paste it right in. And then because I have that value and I want to make sure we set this, even though we've passed it as a parameter, I'm going to do the extra overhead of redoing it again just to make sure it's good. So I'm going to do this selector set value. I'm going to pass it value. Even though we've already assigned it right here as part of the super constructor, just to make sure we've got that covered in our mind, that I'm assigning the value parameter to this node, I'm doing the line right here as an overkill. So this selector set value assigns the value parameter to the node's value data member.
Overkill.
Because this right here, calling the super constructor, passing it value, will do that already. But we want to make sure we've got that completely covered, so I'm doing it right here just to show you that it takes care of it. So we have that basic framework right now. We've got our template class type. We have our constructor. We know it's a constructor because there's no return type. It's just the name of the class ownership, scope resolution marker, and then the constructor call. We have one more constructor to make, and then we'll leave you guys to work on writing your getters and setters on your own. So our next constructor takes 2 parameters. So I'm going to highlight the constructor header because I need to copy that and paste it anyway. And so my first line of code will be what?
Template class type.
Template class type. Then TreeNode type, and then scope resolution, and then paste the header for the constructor. And then a colon, node of type, and pass it the value. So again, I have right here, I have template class type as the prefix because I'm dealing with a generic type. I have the class owner because it's constructor, there is no return type. I have the scope resolution marker that indicates that this constructor belongs to this class. I have the full header for the constructor. So it says the TreeNode PM passing it the parameter list, followed by a colon to show that I'm calling the super constructor of node of type passing it value. So I'm using the super constructor for that. And we're going to see how to do that with the not overkill version in here. So let's do the non-overkill version first. So I still need to have these 2 lines right here automatic, because again, C++, you can't call the constructor from the constructor. So I have to do this set left child and set right child to null pointer. And then I'm going to use the call right here to value. That sets the value for it, so we're doing that implicitly by using just the implicit call of the super constructor. That's this line right here. And then I have to set my parent parameter. So instead of this selector right child or parent equals null pointer, I'm going to assign my parent to be that parent variable. So this selector parent equals parent. So now I have this parent variable right here that is indicated to go into the parent of this class. So this is the non-overkill version of the constructor. So I have, and I'm going to scroll this out a little bit more so you can see this. So in my non-overkill version, I have my template class type that goes with that. I have the class owner scope resolution indicator. So that says this is who owns this constructor. I have my constructor header that says I'm calling the constructor with 2 parameters, a value parameter and a TreeNode parent parameter pointer. I have the colon for inheritance. So I call the super constructor. I call the super constructor of node passing it value. This segment of the line right here is going to go up to my node class. Go to node.cpp. Take the node parameter with a value parameter and assign value into this value. So this is doing the work from here and then goes back to my tree node and then assigns left child, right child, and parent from this parameter. So this value right here, as you can see, is taking that same parameter and shoving it into the nodes constructor. So I use the super constructor for this, assign value implicitly inside my header call, and then I assign my explicitly null pointer to left and right child, explicitly assign parent to this parent node, and my value has already been assigned by this line right here of my header. So we've built our 3 constructors for our node TreeNode class.